Practice 6.3, number 1, determine whether each random variable described below satisfies the conditions for a binomial setting, a geometric setting, or neither. Support your conclusion in each case. Part A, suppose that one of every 100 people in a large community is infected with HIV. You want to identify an HIV positive person to include in a study of an experimental new drug. How many individuals would you expect to have to interview in order to find the person who is HIV positive? This is a geometric setting because you don't know, even though you know that there's 100 people in the community that has HIV, you're going to keep interviewing people until you find one that's positive. So you don't know how many trials that's going to take, so that's why it's not binomial. It says we are looking for the number of independent trials it takes to get the first person who is HIV positive. So again, you're not saying, you know, what's the probability if I interview 100 people that exactly 18 of them are going to be HIV positive. Like, we don't know the number of trials it's going to take before we find the first one who actually is HIV positive. Okay, so that makes it geometric. Part B, deal 7 cards from a standard deck of 52 cards. Let H equal the number of hearts dealt. This is neither binomial nor geometric because each trial is not independent of previous results, since it's done without replacement. The suit of the first card influences the probability of a heart on the second card, and so on. So if you draw one card, so if you're dealing 7 cards, so if you take one card out, then the probability of it being a heart is 1/2. It's, 26 out of 52. But that second card that you pick up, assuming that the first card was a heart, is now going to be 25 out of 51. So they're not independent trials, and so you can't do binomial or geometric unless you would have maybe replacement where you're going to pick a card, reshuffle the deck, and then pick a second card. So the fact that the first probability affects the second probability, that's what makes it neither binomial nor geometric. Okay, number 2, research suggests that about 24% of 12-year-olds in the United States can pick out the state of Colorado on a map. What is the probability that you must sample exactly 5? So it's the probability of X equals 5. 12-year-olds to find the first one who can pick out Colorado on a map. So it's, you're waiting till you find the first one, so that makes it geometric. So what's the probability you must sample exactly 5? So that's assuming that the first 4 got it wrong, because you're going to keep asking kids until somebody gets it right, and then you want the probability that that kid that gets it right is going to be the 5th kid. So that makes it geometric PDF. You have a 0.24 probability. And then you want exactly 5. So notice that I did the PDF because it's exactly 5. And so when you do that on your calculator, you do the GeoMet PDF. It just stands for geometric PDF of 0.24 for your P and then 5 for your X. And so you end up getting about 0.0801. Okay, part B, what is the probability that you must sample 5 or more 12-year-olds to find the first one who can pick out Colorado on a map? So 5 or more would be the probability of X being greater than or equal to 5. So there's not a way on our calculator to use the geometric PDF to get greater than. It only does below. And what I have written on the worksheet is actually wrong. Sorry about that. Change this right here to a C, because we actually need to do 1 minus the geometric CDF, because what we're doing, if we want greater than or equal to 5 out of these 12-year-olds that we're picking, then greater than or equal to 5 would not include 4, 3, 2, 1, and 0. So when we're subtracting from 1, we need to go ahead, because we're going to do 1 minus the geometric CDF of 0.24 for our probability. We're subtracting away the 4, the 3, the 2, the 1, and the 0. We don't want to subtract away the 5 because it is included when you're doing greater than or equal to. Okay, so it's 5 or more. We want to keep the 5. We want to keep 5, keep 6, keep 7, and so on. We want to get rid of 4 and below. So I did, what I did on the calculator here, I did 1 minus geometric CDF of 0.24 comma 4 gives you the correct answer of 0.3336. Sorry about that typo there. That's what I get for copying and pasting. Okay, moving on, number 3. An online poll reported that 20% of respondents subscribed to the 5-second rule. That is, they would eat a piece of food that fell onto the kitchen floor if it was picked up within 5 seconds. Let's assume this figure is accurate for the entire U.S. population, and we select 15 people at random from this population. So we know our the size in our trial is 15. So we know how many people we have, and so that is what makes it binomial. So determine the probability that exactly 3 of the 15 people, so we know we have 15 trials, okay, subscribe to the 5-second rule. So we're going to do the probability of that x equals 3. We're going to do binom PDF because it does say exactly 3. So our number of trials is 15. Our probability of success is 0.2. That's how many people want to eat it off the floor. And we want to know exactly 3 of them. So the fact that we said exactly tells us to do the P. And when you do it on the calculator, you end up getting about 25%, 0.2501. Okay. Part B, find the probability that less than 4. So I'm going to do probability of x being less than 4. People out of the 15, so again we have our number of trials is 15, subscribe to the 5-second rule. We're doing binomial CDF this time because it's not exactly 4, but it's less than 4. So we actually want to know the binom PDF if it's less than 4 of 0, 1, 2, and 3. So technically you could do the binom PDF of 0 plus the binom PDF of 1 plus the binom PDF of 2 plus the binom PDF of 3. You could do that if you wanted to and get the same answer as doing the binom CDF of 3, because what that does is it finds the probability of 3, 2, 1, and 0. The reason we're not including 4 when we do the binom CDF is because we don't have the equal to sign. We only strictly have less than. So it's x is less than 4. So we do not include the 4 when we run it because we don't want it to equal 4. We only want it to strictly be less than 4. Okay, so on your calculator, you'll do the binom CDF. 15 for the trials, 0.2 for the probability of success, and then 3 as your x value. And it ends up giving you 0.6482, so about 65% of the time. Okay. Part C, let F equal the number of people in our sample of 15 who subscribe to the 5-second rule. Find the mean and the standard deviation of F. So we're going to use our formulas. These are actually on the formula sheet for the AP exam, so it's not something you have to memorize. It will say on the AP formula sheet, the AP exam formula sheet, it'll say mu, let me get it in front of me actually, mu x equals NP is what it's saying. And then right below that it says sigma x equals the square root of NP1 minus P. So that's going to be your number of trials times the probability of success times the probability of failure. Because 1 minus P, like if your P is 30%, then 1 minus P is 70%. So you're doing, again, your number of trials times the probability of success times the probability of failure. Okay? And couldn't get it to copy and paste over correctly, so we'll just have to add that work in here. So we have, let me back up a second and do the mean though. So using the mean is equal to NP, your number of trials is 15, and then your probability of success is 0.2, and that's from the scenario. So 15 times 0.2 gives me a mean of 3. Okay, the standard deviation, we would do the standard deviation of F is equal to the square root of N times P times 1 minus P. So essentially what we're doing, the square root of our number of trials is 15, the probability of success is 0.2, and so the probability of failure is 0.8. I did go ahead and type in the 1 minus 0.2 on my calculator instead. That's the same thing as 0.8. So either way, you would get the same answer of 1.54919, so on. And so if we're sticking with kind of the rounding to 4 decimal places, because that's what they pretty much did on the entire worksheet. So we would do the standard deviation of F is 1.5492. Sorry about that. It's just going to be in our way. So 1.5492 if we're rounding correctly. Okay? Sorry about that, guys. So 1.5492 would represent your standard deviation. And again, both of these formulas are not something you need to memorize. They are on the formula sheet, and you are allowed to use that on the daily check as well.